will analyze this simply supported beam. One end is hinged and one end is roller supported. There is a 5 kip concentrated load in mid span. I will use ETABS 9.7 portable version. I have opened this. Now open a new model. I don't want to import any data from an existing file, so press no. See this option, grid dimensions in plan, is very important in ETABS. At first you have to define the grid lines before analyzing a structure. Now in this video I'm going to analyze a simply supported beam. This is a 2D structure, so I have to deal with X direction only. In X direction I have to define 3 grids, because this is a restraint. You have to define a load in mid span, and there is a restraint in right side, so define 3. I have not to deal with the grid line in Y direction. You cannot define it 0, so at least you have to define it 1 or whatever number of story, whatever. Say I'm defining 2, and you have to define the units. Okay, you can go the custom grid spacing also. This will come later when we will analyze a big structure like multi-story building. Now I am keeping the unit in inch. Okay, grid only. Okay, this plan view and this 3D view, as I'm going to drawing moment and shear force diagram, bending moment diagram and shear force diagram, so I need to see the elevation view. Okay, the next step is I have to define the material properties. Definitely the material properties is concrete. I have not studied the steel course yet. Okay, concrete. Okay, now I have to define frame section. So the rectangular beam, we are analyzing a rectangular beam. Section name, say concrete beam 10 by 10 inch. Now material concrete. This is showing the reinforcing bars, but we don't want to see the reinforcing bar. We will design the reinforcing bar. So this is showing for column. Now we have to go in beam. So concrete reinforcement beam. Top cover according to beam is 1.5 and 1.5 when open to nature. Okay, okay, okay. Now draw the beam. Select the material. Simply press C. C, concrete beam. Okay. Now remember that you have to start from the first support and you have to stop here if you want to see the bending moment value or shear force value. Also you can draw at once, but you can see the values if you don't stop or if you did not divide the beam in this way. So simply press escape and this. Okay, now side. Now the beam is located on story 2. I have to assign some supports or restraints before assigning the load. Okay, select the point. I have to assign a hinge support here, so assign joint restraint. This is the mechanism of a support. The translation and rotation about x-axis, y-axis or z-axis. You can simply select the support type here, or if you know the mechanism or in advanced level or in modified support section, you have to define the translation or ability to rotation around x-axis, y-axis, whatever. Now I am selecting hill support, and you can see it permits the translation. It don't permit the translation around x-axis, y-axis or z-axis, but rotation about x-axis, y-axis and z-axis. Though the beam can be rotated along x-axis and z-axis only. Okay, here you go the hill support, and then I have to define the roller support. Select the roller support. It restrains translation only z-axis, so gravity load. Okay, then I have to define the point load, sorry, load force. Now this is definitely the live load, not dead load. Keep in G. Define the load. The 5 kip load is working as towards the gravity load, so for z-axis it will be negative 5 kip. Okay, this is, we have assigned the load. Now I have to save the model. Save the file, define a name, save whatever. Okay, save. Before analyze, set analyze option full 3. Mark the dynamic analysis. This is important for mechanical engineer. Okay, now run the analysis. You can see the deformed shape here. Now this deformed shape is a dead load. For live load, this is for live load. Just want to see the moment diagram. Support spring action, frame pass, support spring action for live load. Okay, this is the moment diagram. The problem we cannot see the deformed shape in elevation view is that we haven't select the tiles here. Now we have select the tiles here. Now show deformed shape for live load, cubic curve. Okay, now you can see the deformed shape for live load. Now support frame reaction for live load. Okay, this is support frame reaction 2.5 and 2.5 support going upward as the load is working downward here for gravity. If you see the member force diagram for frame pair or shape, you have to define the shear force along 2 or moment 2 or shear force 3. This is for each member has 3 axes in ETABS X, Y, Z. X is defined by 1 and colored by red, and the Y axis is defined by 2 and colored is white, and the Z axis is defined by 3 and the color is blue, whatever defined by global axis. You can define shear force as in planar shear and in plane moment also, but in most cases the in plane shear or in plane moment give you the accurate bending moment and shear force diagram, but in if you want to get the shear force diagram and bending moment diagram more accurately, you have to define the shear 2 or shear 3 means the shear along the y axis or z axis. Okay, number 1 axis goes through the member, there will be no shear through axis, hence shear 1 by axial force. Shear 1 is defined the axial force. Shear force works along 2 rest axes, means the y axis and z axis. So you have to visualize the axis in the figure, in the elevation view. Now then you can define the shear working along the axis 2 or shear working along 3 axis. Okay, you can see this option. To see the axis, you have to click the building view option, object view option, the line local axis, you have to take this and then OK. After pressing the OK, you can see the axis. This is the shear is working vertical now, so the shear is working with the white along the white plane, and the sign here. This is for moment, so moment is 3 3, as this is z-axis and defined by 3, and this is y-axis defined by 2, and this is x-axis defined y, axial force, this shear force, and this bending moment. Now we can define the moment and the shear axis. So go the incline shear, okay, whatever. This is the shear force diagram, and go the incline moment. This is the bending moment diagram. If you want to see the moment diagram on tension side, you can see this from here. Okay, this is moment diagram in compression side. As now, if you want to see the values in the diagram, so you have to at first uncheck this option, then show values in diagram, and then the value will be shown here. And for shear force diagram, this is the value. Now the shear force is working along 2 2. If you see, this is the shear force diagram, and if you want to see the shear force working along 3 3, there is no shear force. So the along z-axis there is only moments, and along y-axis there is only shear. If you want to see the energy diagram for live load, show values. Okay, this is the energy, this is the energy or virtual energy diagram, and that's it.